Hello and welcome back. In this video we're going to show you how to simplify rational exponents and how they're used with algebraic expressions. We have an objective. We're going to extend the meaning of exponents to include rational numbers, and a piece of vocabulary here, exponential form. A radical expression is in exponential form when it is expressed as a power or the product of powers. We all know what the powers are. They have those little exponents on it, but how do you change a radical into an exponent? If you watch the previous film, which is an introduction to rational exponents, you'll know that rational exponents have two parts. Okay, so if we have, let's say, a to the b over c power, you'll know that this number on the bottom represents a root, which is like a square root, and this one on the top represents the exponent or the power portion of it. So that would be the c root of a raised to the b power. Or you could take a to the b power and then the c root of that, and it turns out that both of those are equivalencies. So how do you take a radical expression and move it back? Well, let's start by taking an exponent and going forward. If I have a number like 5 to the 1/2 power, that is really the square root of 5 to the first power. So if I have the square root of 5 and I want to write it in exponential form, I know that my power is here and my root is out here, and that creates my fraction 1 over 2, and I just use 5 as my base number. So another example of that would be, let's say I have the third root of 6 to the 5th power, and I want to write that in exponential form. Well, the 5 in here, the exponent, is the numerator of my fraction, and the root number out here is the denominator, and the 6 is the base. So the cube root of 6 to the 5th is the same thing as 6 to the 5/3 power. So we can always work backwards. If it works with the numbers, it'll also work with the variables. So we're going to practice simplifying a few of these and working them from radical expressions back to exponential form. So for our first example here, we have 81 to the 1/4 power. Well, we need to rewrite that with a radical. Remember, this is the root right here, so what we're looking for is the fourth root of 81 to the first power. Well, 81 to the first power is just 81, so what we're really looking for is the fourth root of 81. And you'll probably need a calculator that can do roots. Otherwise, you can just have to guess and check. And most of you are pretty good at this, and you'll find out that this is actually equal to 3. So if you want to be sure, go to your calculator and do 3 times 3 times 3 times 3, because that's 3 to the 4th power, and check to see that it gives you 81. And it turns out that it does, and the quick way to check is to multiply these together. So you get 9 here, you get 9 here. When we multiply those, you get 81. So we do know that 3 to the 4th equals 81. Therefore, the fourth root of 81 is equal to 3. Okay, for our next example, got to keep in mind that this is the exponent of the power, and this is the root. So I have two options. I can do the third root of 64 and then raise it to the second power, or I can do 64 to the second power and then take the third root of that. Well, I'd rather do the top number first. I'd rather do the third root of 64. I happen to know what that is. That happens to be 4. So when I take that and simplify it, instead of having the third root of 64, I get 4 raised to the second power, which is 16. So the 64 to the 2/3 root is equal to 16. And some of you might notice a little bit of a pattern here. This fraction is less than 1, which means the output from 64 is going to be less than 64. If it was bigger than 1, then it should be bigger than 64. Okay, for this example here, we actually have numbers all the way through and not just variables. And I know that some of you remember that when we have a power or an exponent on the outside, it normally means distribute. However, we cannot take an exponent and distribute it across an addition or a subtraction sign here. So what we really have to do is simplify inside the parentheses first and then apply the exponent on the outside. Okay, so I have 25 to the first power, but I'm taking the square root of that. So basically, I'm taking the square root of 25. Plus, again, I have the first 36 to the first power, but I'm taking the square root of that, so I essentially have the square root of 36, and I have a power of 2 on the outside of that. Now use your calculator and find out what the square root of 25 is, which is 5. And the square root of 36 is 6. And they're still inside parentheses, being affected by the power of 2 on the outside. 5 plus 6 then is 11. And then you got 11 squared, and that's going to give you 121. And that's all the way through with the numerical value. In this example here, we have a negative exponent. If you didn't watch the negative exponent video, you want to go back and look at it. Negative exponent just really means the reciprocal of that number. So we're still taking 27 to the first, but the third root of that. So we have 27 to the first power, and we are taking the third root of that. But the negative exponent means this number, which is over 1, needs to be flipped over. So the negative exponent is just a reciprocal. So I need to put a 1 over this. So I really have 1 over the cube root of 27 to the first. And use your calculator to find out that the cube root of 27 is actually 3. So 27 to the negative 1/3 power is actually equal to 1 over 3, or 1/3. For this example, we have a radical here, but we want to put it back into exponential form. Remember, this is a square root. We don't see a 2 there, but when there's not a 2, it's deemed to be a 2. So that's a root 2, or square root. If you have more than one factor underneath the radical, you want to put those in parentheses, and you want to put a little 1 on the outside. Because what we're going to do is get rid of the radical first. We're going to write the radical as 1/2 power. So x to the 5th, y to the 4th, and the radical can be rewritten as the 1/2 power. So the square root of anything is the same thing as anything raised to the 1/2 power. And now we have that fraction on the outside, and we don't have a radical anymore. Give you an example here. We got the square root of some number is going to equal in to that 1/2 power. So the radical means 1/2 power. If I had a cube root of n, that would be to the 1/3 power. Okay, so now we're going to go forward. Since I have an exponent on the outside, I can go ahead and distribute it. So we're going to have x to the 5 times 1/2 for the first one, and y to the 4 times 1/2 for the second one. And the first one, we're just going to have to call it x to the 5 over 2 and times y. And on the second one, we're going to have 4 over 2. This is going to come out to 4 over 2 when we multiply, but 4 over 2 is simply 2. So if we say rewrite this in exponential form, what we mean to do is put it back in this form here, where we have no radicals and we have exponents only. And since you have a radical in the original problem, it's a high likelihood you're going to have a fractional exponent, because fractional exponents always represent a power and a radical or root in the denominator. Here's another example where we have multiple parts underneath the radical sign, and what you want to do first is put that in parentheses, and you want to put a 1 on the outside. So a fourth root is really a 1/4 power. So we're going to rewrite that with a 1/4 power. So we'll put our big parentheses here, 1/4, because that's the fourth root. But in the numerator, we have a 3 to the 4th power times a to the negative 6 over b to the 2nd power. We can actually distribute this 1/4 all the way through to each of these exponents, including the denominator. So 3 to the 4th gets multiplied by this power on the outside, so does the negative 6 and the 2. So I'm going to write it in long form, so it's going to be 3 to the 4th times 1/4 multiplied by a to the negative 6 times 1/4 over b to the 2nd times 1/4. Now we're going to multiply them together. This is 4 over 1, so 4 over 1 times 1 over 4 gives me 3 to the 1st power, or just 3, times, and over here we have a negative 6 times 1/4 is going to give us a negative 6/4, and I'm going to reduce that to negative 3/2. So a to the negative 3 over 2 power. And yes, there is a negative exponent there, and we'll deal with that in a moment. Put your fraction bar. And this is going to be 2 over 1 times 1 over 4, which is going to give us 2 over 4, which is 1/2 power, so b to the 1/2 power. And here's something we probably aren't used to seeing yet. We know how to work with negative exponents, but we've never seen a negative exponent inside of a bigger fraction. Yes, we do know that negative exponents mean reciprocal. So in order to get rid of that negative exponent, all we're going to do is take this entire thing and move it down to the denominator and leave it as a positive exponent. So we're going to call this 3 over b to the 1/2 times a to the positive 3 over 2. And now we have a positive exponent instead of a negative exponent.